Hi everyone, I'm Doug Alsdorf, and in this short video, let's have a look at the quiz question number 2 for chapter 13. Chapter 13 is my favorite chapter. And we're going to go to the WordPress page. We're going to have a look at the quizzes and have a look at the question for chapter 13, quiz question number 2. I'm going to scroll down here, and we need to download the spreadsheet S&P 500 moving. So let's go back to the WordPress page and go find the spreadsheet. So that's click on spreadsheets, scroll down to chapter 13, and we wanted the moving spreadsheet. And we'll go ahead and open that. And I'm going to make this a little bigger so that it's easier to see in the zoom window so we can see the entry of the values. And I think the question sets it up so that the defaults probably will work for us. Let's double check. So we are wondering what is the average gain in the S&P 500 when reinvesting dividends. That's what this spreadsheet does. It has a look at the S&P 500 over decades and decades. And you can read the book to learn a lot more about it. It's so exciting to see this work. What is the average gain from a $50,000 investment when investing in the S&P 500, reinvesting dividends in the time frame between 1935 and 2024 for any 35-year window? So let's set that up. There's 35 entered there, 50,000 there, and that's just a value for comparison. And now down here, I then ask let's see here. I should be asking here, what is the average gain? What is the average gain? And I invite you in the question to scroll down to these cells I-34, 35, and 36. So we're just going to scroll down here to I-34, 35, and 36. And you can see up in the upper left, it's highlighting for us what is the cell number. And there's the number. That is the average gain from 1970 to 2024. But remember, the window starts in 1935, ends in 1970, starts in 1936, ends in 1971, starts in 1937, ends in 1972, and so on. Actually, I increment it by month, but that gives you the idea of how that works. And that's why the statistics, and I'll show you in a moment, in the plot are being calculated just from 1970 to 2024, midway through 2024 in this data set. So we see that the average gain on a $50,000 investment 35 years later is 1.98 million. Let's see what our choices are. And so we see, yeah, there's 1.98 million. Then I ask, what is the standard deviation? Standard deviation looks like $370,000. And there's that choice. And by the way, let's write those down. 1.98, $370,000. What's the value after subtracting one standard deviation? So we're just going to look at this, and I actually don't provide that number in the spreadsheet, but if you just kind of eyeball this, 1.98 minus 370, that looks like about 1.6. So we'll write down 1.6 million. What's the average after adding one standard deviation? So we're going to take 1.98 and add about 370. So that should be around 2.35 million. So we'll select that. And then I ask, between those two calculations, between subtracting one standard deviation and adding one standard deviation, how much of the data, in other words, how much of the time would you have done within those boundaries? And well, as it turns out, the answer is 68%. For those of you who know how statistics are calculated, that would be the answer. So let's scroll down to the answers for the quiz question here. This would be question number 2. Sorry, I just blew right by it, didn't I? Right there. Sorry. I'm so excited. This is my favorite chapter. 1.98. Yeah, that's what we wrote down. 370,000, 1.61. We wrote that down. 2.35 and 68. By definition, one standard deviation represents 34% of the data if it's normally distributed. We're going to have a look at that in just a second. So adding and subtracting one standard deviation means we've encompassed 68% of the data. All right, let me put this window away so we can have a much closer look at the spreadsheet. And so we're going to take those same values. And the great thing about this spreadsheet, there's only 3 parameters to enter, but let's have a look at the plot. And now we see this is the data right here, anywhere along this timeline. That's how much money you would have made 35 years later. So we invested in 1970, or rather we invested in 1935. 35 years later is 1970. So each one of these values represents starting 35 years prior to the plotted value. That's how much money you would have made after 35 years. Look how all those values are around $2 million. That's the average for all those. And we're only going to calculate the statistics starting right here where that dashed line starts. So in the book, I explain that we're only calculating the statistics for just those numbers. This is really fantastic for us to understand what the potential growth is. But now we got the spreadsheet set up, let's have a look at a different time. Instead of investing for 35 years, how about 20? 35 years can be a long time. Some of you may not have even been alive for 35 years. How about 20 years? So we're going to just use a 20-year investment timeline. How does the numbers change? Well, here you can visually see the data isn't quite normally distributed. We got a couple of spikes here, and that's kind of a little outside of being normally distributed, but we're just going to bear with that. But the thing you're seeing already is these blue values in through here. They're what, 4 to 600,000? They're not millions of dollars, they're hundreds of thousands. Let's see what the average value is for that investment for the time frame we're talking about. In this case, 20 years after 1935, that's 1955 to 2024 and a half, 473,000. Takes 20 years to get to $473,000 when investing 50,000, just one time, 50,000, wait 20 years, 473,000. But it only took 15 years to get another $1.5 million. So it takes a lot of time, but once you get it going, you can really do well because of the way investments work. So I hope this is helpful for you, and I invite you to really spend some time on chapter 13. It is my favorite chapter in the book.